right, here we go, kids. Here we go. We're on day 7. Day 7. I'm trying to teach you how to factor polynomials. We got 3 different scenarios going on here. We've got if we have 2 terms, 3 terms, and 4 terms. Well, 2 terms, you'll notice that every one of these starts out with, hey, do you have a GCF? Then, for 2 terms, you're looking for the difference of perfect squares. Or, because based on what we did yesterday, now you're looking for the sum or difference of perfect cubes. You cannot factor the sum of perfect squares, only the sum of perfect cubes and the difference. If it's 3 terms, again, look for GCF, but then factor it into 2 binomials. And then this one, if it's 4 terms, we're going to first always look for a GCF, split it down the middle, and then just GCF, GCF, GCF. All right, we'll talk about those again. We'll remind yourself. So this is a practice day. Practice. So first thing here, I'm going to take out an X. This may look different than I have. Hopefully I'll update the file online. If it looks differently than this, change it, please. But the first thing I'm going to do is take out an X. I don't know. I sort of wrote down a few problems that were wrong. So I get X squared minus X minus 6. But you got to keep factoring. I want to keep factoring this. So it's X minus 3, X plus 2. And then I'm done. Factored completely. Here, take out an X. I'm left with X squared plus X minus 12. I need to multiply 2 ways and multiply to 12, or negative 12, and add up to positive 1. So the larger number will have to be positive, and you're looking for 2 numbers that are 1 away from each other, 4 and 3. But since this is positive, the larger one has to be positive, and the smaller one has to be negative. We've done this a million times, a bazillion times. They're all even. I can take out a 2, but I can also take out an X. And I'm left with X squared plus 4X minus 45. So I'm looking for 2 numbers that multiply to 45 that have a difference of 4. Well, the easiest number that goes into 45 is 5 or 15 maybe, I guess. And then it's 5 is the answer. Plus 9 and minus 5. They have a difference of 4 and they multiply to negative 45. Are these the sum of perfect cubes? It's a binomial. Well, first of all, I'm looking for a GCF. I don't have one. But this is really 2x cubed, and this is really 3 cubed. Yes, this is similar to problems we probably did yesterday in class, but you can only do so many sum and difference of perfect cubes, and they start all looking alike. If you get stuck, have some coffee. I always take care of the signs first. Copy, change, always positive. In this first one, we'll go just the 2x. Oops. In the second one, we'll go the 3. At the beginning here, we'll go this squared, 4x squared. At this one here, we'll go this squared, 9. And then I just multiply the 2 to get me the middle term, 6x. That's it. That's all there is to it. All done. We got 4 terms, so we got to split. By the way, you should probably practice these on your own. When I go over these in class, I'm going to stop, give you plenty of wait time. You have a pause button. I don't want this video to be an hour, nor do I want it to take me an hour. So I'm not going to pause, but you can pause. Take a look at the problems. Do them. In this beginning, I can take out an x squared. I'm left with x plus 2. Now you got to be careful. This sign gets copied over, minus. Now I'm going to factor out a 25. And I've got x plus 2 here. I think this is the first time you've done factor by grouping. Factor by grouping works this way. I look at the first 2 and I look at the second 2 and I say, what can I take out? What is the GCF? I originally looked at it, and I should have said that. I originally looked at the problem and said, hey, there's no GCF. Then what I want to do is group it into 2 things. I want to group it into the first 2 terms and the second 2 terms. And I want to look for a GCF. In this case, I had an x squared. In this case, don't forget, we want to copy over the sign, and I say don't forget, but it's probably the first time you're hearing it. And then I'm looking at 25 and 50. Now, why is this x plus 2? Well, this is negative 25 times positive 2, and that gives me negative 50. The other thing I want to remind you or tell you is these two things need to match. They need to match. So that's my first one, x plus 2. And I'm left with x squared minus 25. Well, I'm not done because this can be factored. So x plus 2, x plus 5, x minus 5. And I'm done. All right. This is the difference of perfect squares. These are not cubes. 25 is not a cube, and that's not a cube. But they are squares. So I'm just going to write it as the difference of perfect squares. X squared plus 5, x squared minus 5. That's it. That's all there is to it. Only because this is not a difference of perfect squares, I can't keep going. Here I can take out a 2. You're going to see this one's got some crazy amounts of factoring. 2, x to the 4th minus 16. But this now is the difference of perfect squares. Notice I'm always looking for a GCF first. Always, 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 always GCF. So now I'm going to factor this. It's x squared and x squared, 4 and 4, one's plus, one's minus. However, this is the difference of perfect squares, so we're not done. Take out a 2, and I'm left with x squared. I'm not taking out 2. I'm just going to copy down the 2. And then this thing can be factored to x plus 2, x minus 2. So when I say completely factor, you got to keep looking. Even when you think you're done, may not be done. I can take out a 2. This would be 8, and this would be 128. But that means I can take out another 2. This would be 4, and this would be 64. But that means I can take out another 2. That would be 2, and this would be 32. But that means I could take out another 2. This would be 1, and this would be 16. So the biggest GCF, and I'm just my stupid way of telling you, is the GCF is 16. And I'm left with x to the 4th minus 16. Wait a second. I just did that over here. So let's cheat. 16, I know it's x squared plus 4, x plus 2, x minus 2. I'm just cheating a little bit right there. The only difference is the GCF on these two problems. All right. Here I'm going to take out a 2 and an x. I think that's it. This leaves me 125x cubed plus 64. Now don't forget, if it's a binomial, you're looking for the difference of perfect squares. It's not difference. Or you're looking for the difference or sum of perfect cubes. And hopefully you recognize 125 and 64 as perfect cubes. And they are. This is 5x cubed and this is 4 cubed. What's the first thing you're going to do? Binomial, trinomial. Copy over the signs or put the signs in. Copy, change, always positive. All right, so in the first one just goes whatever those two things are, 5x and 4. In here goes the first thing squared, 25x squared. At the end goes the other thing squared, 16. And in the middle goes the product of the two, 20x. We've got 4 terms, so we're looking for a GCF. We're going to group them. We're going to group these two together. Copy over the sign. And group these two together. So in the first two, I can take out a 3x. And I'm left with, oh, excuse me, I'm taking out a 3x cubed. And I'm left with x minus 2. In this one, I'm going to take out a 5. Weird. Because the only I can take out here is 5, and I'm left with x squared minus 2. But these are supposed to match. So perhaps this should have been a 5. So if that's a 5, I can still only take out, that's x squared minus 2. So I get x squared minus 2, 3x cubed minus 5. All right, that's it. Those aren't difference of perfect cubes, so you can't done. Hopefully I don't run into any more problems. I thought I got rid of all the problems. So here I'm going to take out an x squared, and I'm left with x minus 7. Plus, copy over the sign. Here I can take out a 4, and I'm left with x minus 7. This leaves me x minus 7, that goes at the beginning, and x squared plus 4. Now that's the sum of perfect squares. You can't do anything with that, so that's your final answer. Let's keep going. Group and group. In the first team, group. I am group. I am group. I am group. I think it's I'm group. Take out an x squared. I'm left with x plus 5. Copy over the sign. It's a minus. Take out a 9. I'm left with x plus 5. So the first thing I'm going to do is take out this GCF, which is x plus 5, and I'm left with x squared minus 9. Now, eventually you're going to get good enough and say, oh, that's x squared minus 9. That's x plus 3, x minus 3. But for now, we're just going to do it this way. X plus 3, x minus 3. And there it is, finally factored. Keep going. Take out a GCF. We're going to group. Anytime there's 4 of them, I am group. I got to figure out what that is. Love coffee. We're going to take out a 4x squared. What am I left with? X plus 2. Copy over the sign, minus. I can take out a 9. I'm left with x plus 2. Some of you are still struggling where I'm getting this x plus 2 from. Negative 9 times positive 2 is negative 18. So when you actually take out a negative number, you have to change the sign of everything on the inside. So now, we're going to try to be smart about this. We're going to take out the x plus 2. Now, the next thing I would generally write right here is 4x squared minus 9. But isn't that the difference of perfect squares? So can't I immediately just say, oh yeah, that's 2x and 2x. One's plus, one's minus, 3 and 3. We've done difference of perfect squares so many times, it should be obvious. Over here, I don't have a number I can take out of both, and I don't have a forgot what I was going to say. I don't have a number, and I don't have a variable that I can take out of both. So I'm thinking this might be the difference of perfect cubes. This would be a cubed. This would be something b cubed. Let's see. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. And 7 cubed is 343. I know you knew that. I know you knew it. You knew it. I know you did. So this is 7. Oh, we got a plus here. So in order to do sum of perfect cubes, we're going to do binomial, trinomial. Copy over the sign. Change it. Last one's always positive. At the beginning goes the two things, a and 7b. Here goes the first thing squared, so that would be a squared. Be careful, we're going to square this. 49b squared. Common mistake. You just write 7b squared. That's a common mistake. And in the middle goes the product of the two. 7ab. All right. We're almost done. GCF. Always look for a GCF. I'm almost done. I got like 10 more problems. Take out a GCF. 2x. And I'm left with 16x to the 4th minus 1. This is the difference of perfect squares. So 2x, 16x squared plus, brain fart, 4x squared plus 1, 4x squared minus 1. Don't stop. This is the difference of perfect squares. You just got to keep looking for it. Sometimes you're not done for a while. You can't do anything with 4x squared plus 1. Sums of perfect squares we can't do anything with. Cubes we can. This is 2x plus 1 and 2x minus 1. We're just going to factor this puppy. It's x squared and x squared. What multiplies to 6 that adds up to 7? Oh, plus 6 plus 1. They're the sum of perfect squares, so I can't do anything with them. I'm done. Finished. Over here, I can take out an x squared. So I'm going to take out an x squared, and I'm left with 35x to the 4th plus 12x squared plus 1. Just because you took everything out doesn't mean there's not a 1 left there. Don't mess with me, kid. Now we got to keep factoring. Well, the easiest way to multiply to 35 is 7x and 5x. The only way to multiply to 1 is 1 times 1, unless you want to add fractions, and we're not doing fractions because we don't like fractions. The signs are going to be the same, and they're both going to be plus. Let's see if that makes any sense. 7x, 5x, that's 12x squared. Oh, wait a second. We got x to the 4th here. Common mistake. Not realizing it's 7x squared and 5x squared. These are the sum of perfect squares, so you're done. There's your answer. We can take out an x, but I can also, let's see, do you guys know the divisibility rule for 3? If you add up the digits and that's divisible by 3, the whole number is divisible by 3. So that's 6, that's 9, and that's 9. So since those are all divisible by 3, I know I can take out a 3. But I'm actually going to take out a 3x because they all have an x. Let's see what's left over. 5x to the 4th minus 24x squared minus 36. Pretty sure that's right. So 3x. Now it's got to be 5x squared and x squared. I just don't know what the rest of it's going to be. So they got to multiply to 36 and add up. So the easiest way to multiply to 36 is 6 and 6. Let's see if that works. That's 30, and that's 6, and I can make a 24 out of that. So since I want the larger thing to be negative, this has to be a minus, and this has to be a plus. So there's my final answer. Since those are not perfect squares, I can't finish them. See how this is not a perfect square, and these are not. This 6 is not a perfect square. Ooh, 4 things we group. This one's kind of tricky. I'm going to take out an x squared, and I'm left with, don't forget, we got to put a plus sign in there, x plus 1. Well, you say to yourself, there's really nothing I can take out of here. If there's nothing to take out a 1. 1. And I'm left with x plus 1. So there's really nothing exciting. So now they have an x plus 1 in common. That's my first set of parentheses. My second set of parentheses is whatever's left over, which in this case is just x squared plus 1. Since that's a sum of perfect squares, I can't do anything with it, so I'm finished. Remember, you should be pausing these things. Stop watching me. I'm going to go through them rather quickly. You try them, and then you work with me and see how you do with them. Here. Nothing can be factored out. So I'm left with 3x squared and x squared. The easiest way to multiply to 64 or 24 is 4 times 6. But I can't put the 6 here, so I'm going to try the 4 here and the 6 here. Let's see. That's 18 and 4. That ain't going to work. The other way to multiply to 24 is 3 and 8. I can't put the 3 here, so I'm going to put the 8 here and the 3 here. Let's see if that makes sense. 9 and 8. Ooh, I can make a 1 with that. Let's say I want it to be negative, so negative 3 and positive 8. Now, since these are not, this is not a perfect cube or square, and this is not a perfect square, I'm finished. You do have to look for it to see if it's still there, but in this case, I'm in pretty good shape. 4 left, kids. Grouping. Over here, I can take out an x squared. I'm left with x minus 3. Take out a minus 9. This should be a 27. Sorry. X minus 3. Got a few things to fix. So my first thing is x minus 3. I'll fix them in class. I think I've already printed these, so x squared minus 9. Oh, wait a second. I didn't need to write that. I realized that, hey, this comes out. I'm left with x squared minus 9, and that is x plus 3, x minus 3. Maybe you recognize it, maybe you don't. Ready? We're going to factor. This one's got this one. Oh, this one's not bad. X squared and x squared. They multiply to 45 and add up to 14. Negative 14. That means, wait, both signs are going to be the same and they're both going to be negative. That's minus 5 and minus 9. Now, this is not the difference of perfect squares, but this is. So we got to keep going. X squared minus 5, x plus 3, x minus 3. So you're going to have to learn to persevere. You're going to have to learn to keep going, keep trying things. All right. Take out a GCF. Take out a GCF. So I take out a 25x squared. I'm left with x minus 4. Take out, copy over the sign minus. Now, there's nothing that these have in common. So really what I'm taking out is a minus 1. Since they have nothing in common, I take out a 1. I'm left with, wait, I took out a negative 1, so the signs have to change. And don't forget, these have to match. So those are my first set of parentheses, x minus 4. That's the GCF, x minus 4. And what I'm left over with is a perfect square here and a perfect square here. So doesn't that factor to the difference of perfect squares? 5x plus 1, 5x minus 1. And there's my answer. Almost done. Last problem. I can take out an n. I can't take out anything. That's an n and that's an m. That's a perfect cube. Is 64 a perfect cube? Let's go back to our perfect cube list. Yep, 64. It's on our list. There it is. So 64 is a perfect cube too, right? So this is really m cubed plus 4n cubed. So binomial, trinomial, copy over the sign, change it. Last one's always positive. In here goes whatever those things are, m, 4n. In here goes those things squared, m squared, 16n squared. And then in the middle, just the product of the two, 4mn. And that's it, kids. That's all she wrote. That's it. I hope you enjoyed your lesson in holy crap, lots of factoring. All right. Bye. Catch you on the flip side. Bye.